Hello everyone, welcome again. In last section, we talked about the theoretical part of machine learning types, where we discuss supervised learning. They're broadly divided in two parts. One is regression and classification. Regression is used for predicting the numerical values for continuous data, and classification used for predicting categorical data. Now we start the practical of machine learning ML.NET using regression method. Today I'll come up with very interesting topic. You can utilize the .NET interactive extension in Visual Studio Code that is come up with .NET extension pack. So you can configure this in your Visual Studio Code. Let me prepare you one of the file for regression. Yeah, as you aware, in last, we already discussed in very detailed way about the data cleaning. The as you if you are aware about it, or if you escape or don't know now, we can talk just and briefly describe the concept of machine learning pipeline. Here you can see we do have raw data, and then we load the data into ML model or in iData view, and then we perform the data pre-processing where we deal with the missing values, encoding, one hot encoding, normalization, min-max. We performed, then we did the transformation, and now we already did these sections, these parts in our earlier sections. Today I will talk about model training. So in the model training regression part, we will talk. Then we will evaluate the model performance. And finally, we create our model. It is next section would be very interesting. Today's session and next session definitely would be very interesting and practical. So I request to everyone, please start your practice if you didn't start yet. All right, let's start a file called regression.ipynb. That is the notebook we will add over here. In this notebook, we can, this is pretty easy and it's good for learning purpose in the interactive way. So you can see the .NET interactive is, yeah, the, so let's select the .NET interactive and then you can start working on it. So I can have regression. Okay, let's start with importing the namespace or the NuGet package, not namespace. We will use this to import ML.NET. Once ML.NET imported, NuGet is imported, then we use the namespaces. There are some namespaces that we will use. Great. Microsoft .NET provides several machine learning trainers. We can have a look what are the trainers offered by Microsoft for the regression method. Here you can see, let's have a look on it. So in ML.NET, ML.NET provides some algorithms, and they provide the trainers for uh, linear regression or regression method. You can see. Okay, let's click on this link, ML.NET task. In ML.NET task, you can see the tasks offered by ML.NET. Here you can see the regression. It's a branch of supervised machine learning, and several trainers already provided by ML.NET. Going forward, or in our current session, we will utilize one by one these trainers. The purpose of these trainers is to predict the value based on our data, based on our training data. It's predicting the value. There are several trainers available in Microsoft ML.NET platform. The important thing here now is started with the machine learning, and you need to learn more and more research papers, how research been conducted for developing methods, developing models. I will share you some examples of research paper or some research papers where you can go in detail and learn about those research papers. So coming back to our notebook, here we have we included the packages, and we already added the NuGet package. And now let's continue with this. Let me copy the code. As you already aware, in last session we have done this practice. So we created ML context class. Let's add here ML context and then load the file. No. Oh, okay. This happens because this is the .NET Interactive that I enabled with Visual Studio Code. Earlier, we have done all the practices in Visual Studio, and now it required the assembly path. So we need to provide the assembly path with this. Let me add this assembly path. You can see we have ML.NET project, so we need to offer the path of our DLL. This is the path, and now we can, oh, still there is an error. Okay, now it is not detecting the house price CSV because house price CSV, it's not located on the root. It is available inside this folder. So not an issue. We can try it out to provide the path. Or the simplest form is use this file in the root label. Great. Now you can see the file is loaded. Let me copy the methods which we already created in our last session. These are the methods which we created. That method used for displaying the data. We created this method. Let's utilize this for data display. And in last section, we have done about the data pipelining process, which we already finished. The data pipeline procedure, where we discuss about the replacement of missing values, and then one hot encoding. We have done the normalization. We have done concatenation. We have done these all features we have done in our last section. Let me copy here. Okay, let's see. We have already done these all things. Simply execute this. You can execute this using Control Enter or just pressing this button. You can see it's perfect now. And now we have done this, so we need to perform fit. Okay, the fit transform. You can see the IntelliSense is working. It's great. So pipeline, it is created here, and then we perform fit and transform. This fit and transform is used to adapt our pipeline and then gives data after the fitting and transformation of the pipeline. And this preview will take the 10 rows, so you can check over here what happened. I simplified this. Let's make a pipeline simple. Replacement of missing value. We can add multiple columns here, as you already aware it. If you like to provide the size, if you wanted to add more, you are free to add this. So this would be perform the replacing value of your columns, and then one hot encoding for the other columns, and further I concatenate these encoded columns into feature columns, and after applying those, added a normalization. So let's do this. And this part was already discussed. Size. Okay. This was already discussed in our last section when we talked about the data cleaning activities. What happened? Let me remove this one by one. Okay. Now you can see we loaded the data. As you can see, the data is presented here. This data is loaded, and this data is completely cleaned data which we have created. All right. Now let's understand how to work with a regression model. What are the steps we need to perform on that? So the first stage is, as we seen over here, we already created our pipeline till here. We have performed the transformation. We also performed the missing values and encoding normalization. And now the topic comes for the model training, how we will do that. So here we'll perform some parts. You can see over here. First is the pipeline is created, data is normalized. Now we use train and split, train and test data. We will see training data and test data. So the approach we will follow 80-20. 80% of this data set which we have, we will split the data set into two sections. 80% for training of the data and 20% as a test data. We will do that. And then we will add machine learning trainer in our pipeline and then evaluate the performance of trainer. Now train the model. Train the model. We will provide the model training here. How to provide model training? Let's have a look. Our pipeline was created. Let's use pipeline and then pipeline.append regression. You will use ML context.regression trainer. There are several trainer in ML in the regression. We will use some most of the trainers we will definitely use. Let's use any one of that for first our training purpose. Let's use this. When you use the model, the trainer, then it will ask you the label column name. So what we wanted to predict in this regression method, we want to predict the house price based on the several parameters which we do have. So the feature column is already, you can see here, is combination of several categorical column. So we will have a feature column and price column. Price column we will predict based on these features. You can see in our class, I already prepared the prediction that we will utilize later. I will show you how to utilize. So let's start one by one. Here we add the trainer into our pipeline. We can achieve this in other way. Let's append uh, the regression into our pipeline. ML context dot regression dot trainer dot any of the regression we'll use SDCA. Let's use this. I will explain later what are the purpose and what is mean by these trainers. So for training purpose and for the beginning, let's try to understand first. Here we will provide the label column name, which is price, and then feature column name, that is features. Okay, that's fine. That's executed. So we added the here we added the trainer in our pipeline, and now let's split the data. Split and train the model. So ML context data dot train split test data. Here we will provide our data and then we will split into test fraction 0.2. This means 20% we will keep for training and 20% we will keep for testing and 80% we will keep for training. So once we split the data, now we will train the model. So train the model. Here we can use where model is equal to pipeline dot fit. Here we will provide the data, and in this case for fit we will use our split dot train date split dot train set, where it is. Let's execute this line first so that we will receive the values in the split variable. Use split dot train set. Okay, we you can see we have earlier we added the regression method or the trainer in our pipeline. Then we split our train and test data and then train the model based on the training data, and now we will perform the evaluation of the model based on the test data. Evaluate evaluate the model, and here we can see where prediction is equal to model dot transform split dot test set. We will predict our model on the test set. How this evaluation will be done? We will use matrix. So for the machine learning models, there are several matrix which will gives us the model accuracy. So uh, we will let's have a look. The model accuracy or the evaluation of the model is very important because model could be underfit or overfit. To judge this, we need to check the evaluation matrix. So for this, we will use matrix is equal to ml context dot regression. Under regression, we have evaluate method, and this evaluate we will provide the prediction as the upper variable. You can see the prediction based on the test data which we created, and then label column name, and our column name is price. Execute this. Ah, okay, good. So it's executed. Now, what is the evaluation matrix of regression? Let's try to understand that. Let's see regression evaluation matrices. We will see what are the evaluation matrix of the regression, how we can evaluate our model performance. So mean absolute error, mean squared error, root mean square error. These are the matrices we can see for our model, how accurate our model is created, or how what accuracy level is offered by our model. Okay, let's use the evaluation matrix. Evaluation matrices. R square is one of it. So let's see the evaluation matrix. Here we can add three. I have three. I've already prepared three matrices. RMSE, root mean square error, mean absolute error, and R squared error for our model. Here you can see the performance, what is the accuracy of our model. In the pipelining, earlier there was some errors, so I recreated the pipeline. I will upload this code to our video. You can do the practice on that. So in this pipelining, I have one column. I use the one column, but you can use multiple columns for the replacing of value, because we cannot move with nan value or missing values. And then I use the one hot encoding of categorical column, as we already aware that we must have numerical values for training our model, because then it gives you the accuracy. As you can see in the uh, just before that, the model gives us -0. -0 means nothing. Model is just guessing with your data. So that means the training was not perfectly done. So that's why I recreated the pipeline. Here, this pipeline I gave in here I gave in all the features that we do have. City, localities, facing. So all columns I provided here. After the categorical columns, we have done one hot encoding that I hope you're aware about the one hot encoding to make a category, a numerical category of categorical column. So let's execute this pipeline and then split the data, provide the training to our model, and then transform the data and do the predictions. And here we will check the matrices, evaluation matrices. Here you can see R2 square. This is very important matrix. This means if value is 1 means your model doing the 100% predictions, means your accuracy of your model is higher. 1 means 100%, but it is very near. 0.97 means our model accurately gives value 97% accuracy our model providing to us. This is 97.76 means 98% accurate value our model provide. If it's 0, this means your model is just guessing. It's not good. You have to look into your pipeline or your training of your model. It might be possible the wrong data is enabled in that. As you seen earlier, it was given only -0. That means nothing. Your model, our model was not good. So now our model is giving good value. So 0.977, this means it's 98% accuracy is given by model. This is the matrix. We can have a look how we can predict the further values with our model. Let me add for you. For this, let's use sample prediction, and where use engine is equal to ml context dot model dot create prediction engine. It will ask two things. One is your the data contract. What is your data contract? So our data is this housing data, and then prediction. So prediction, prediction, and then provide the model to this. Okay. Done. Let's have a input of date input. Let's say I have some data, sample of data that I will pass to this model and predict the price. As we have seen, our model already gives 98% accuracy, approx 98%. How we will perform this? Here we can write predict, predict, prediction result, engine.predicts, and we will provide the sample data, and let's say the prediction result price. The score. Now, based on these parameters, the data model predict the house sample house price is this house price is predicted by the model based on these values here. We have, let's say, if we change some values, then the prediction would be changed. Here you can see some values would be changed. In this case, we have lift or we don't have lift, and this is how many bedrooms you have, what is the area, how many floors. Based on this data, your values, yeah, you can see the values are changed. And how many balconies are there, schools nearby, hospitals nearby. So these are all the deciding factor of we have parking or we don't have parking. uh, when it is renovated, we says okay, it's renovated recently. When it was built, it said it was built in 2000. Then based on these things, our model predict. You can see the values changing based on those parameters. We said okay, we do have 2 bedrooms and then we have 2 bathrooms. Our area is 2000 square feet living area, and then this lot area is 2500, and number of floors, I would say 20 floors. Then you change, as you change the data, your price would be changed. Can you see? So this is the beauty of machine learning model, isn't it? It seems interesting to you. Looking forward, and I would like to hear from you based on your practice. I will upload this interactive notebook on our video on YouTube, or yeah, or the applicable platforms. You can have a look. In next sections, we will talk more about the trainers, what are the trainers and what are the errors, how we know the model is underfit or overfit. We will talk on those topics in next session. Thank you very much. Stay tuned. Have a practice. Good day.